Section 7.5, Sum and Difference Formulas. Sum and difference formulas for sine, cosine, and tangent, and we're gonna see how to apply them. So the sum and difference formulas, what are they? And let's start with the cosine first. So what is cosine alpha plus beta? That's what it is. That does not equal cosine alpha plus cosine beta. You can't just like kind of distribute it in. And we're not gonna go through the proof for now. This is just cosine is defined as cosine cosine. So cosine alpha cosine beta minus sine alpha sine beta. So the middle sign gets switched from plus to minus. So the same thing happened with cosine alpha minus beta. So that's cosine alpha cosine beta plus sine alpha sine beta. Sine alpha sine beta. And how do we apply this? Like why this is useful? Let's say someone asks us to find the value of cosine 15 degrees without using a calculator. We don't know what that is. If you draw this on the unit circle, it's not going to be easy to find. But what we can do, we can use what we just learned to rewrite 15 as either the sum or difference of two angles that we are familiar with. Familiar means we can find their sine and cosine. Maybe 45 and 30, so 45 minus 30, or 60 minus 45. It doesn't matter which one, because we're familiar with both cases. And then you can apply the second formula up there. So cosine the first angle, cosine the second angle, plus sine the first angle, sine the second angle. And let's see what we have here. What we have, cosine 45 is the square root of 2 over 2. Cosine 30 square root of 3 over 2. Sine 45 square root of 2 over 2. And the sine is 1/2. So that gives us square root of 6 over 4 plus square root of 2 over 4. So the answer is square root of 6 plus square root of 2 over 4. See, we were able to find it using these formulas without using a calculator. Is there a formula for sine? Yes. Sine alpha plus beta. The formula for this is sine the first angle cosine the second angle plus cosine alpha sine beta. So the middle sign stays the same, it doesn't change. This stays matches in the sign. Some people memorize it as using the first letters SCCS. Same thing with alpha minus beta, exactly the same formula. So sine alpha cosine beta minus cosine alpha sine beta. Okay, so that's what we have. Those are the sum and difference identities for sine. How do you apply it? Let's say we're asked to find the value of sine pi over 12. And if you don't know what that is, you are welcome to convert this into degrees first and then see it, what it is. So let's look at that sine pi over 12. So let's say I don't know what that is in degrees. One trick to do this is to rewrite this as 4 pi minus 3 pi. Okay, so why did we do this? Because the 3 and the 4, they go with the 12. So we can split this over 12 minus 3 pi over 12. And that gives us sine pi over 3 minus pi over 4. So that gives us, now it looks like sine alpha minus beta. So sine cosine minus cosine sine. So pi over 3 is 60 degrees. Sine 60 is the square root of 3 over 2. This is 45, square root of 2 over 2. This is 1/2. And the last one, square root of 2 over 2. So that gives us an answer, square root of 6 over 4 minus 2 over 4. Combine them. as more applications or more practice, let cosine alpha be 3/5, where alpha is in 3 pi over 2 to 2 pi, that's 4 quadrant. And sine beta, -2 over square root of 5. Beta is from pi to 3 pi over 2, that's 3rd quadrant. We need to find the value of part A, sine alpha, part B, cosine beta, part C, cosine alpha minus beta, part D, sine alpha plus beta. So let's see what we get from the first one. I need cosine alpha from sine alpha from cosine. So the first thing I do, I draw a triangle, alpha. Cosine is the adjacent over the hypotenuse. It's given. So by the 3, 4, 5 right triangle or the Pythagorean theorem, you can find this side is 4, and I always draw the unit circle, and I'm working somewhere here. So alpha is located somewhere here. The next one that will help us is a triangle for beta. So I'm gonna draw a beta here. Sine, forget about the negative sign for now. Sine is the opposite over the hypotenuse. Opposite over the hypotenuse. So then what goes in here? 5 minus 4, that's a 1 by the Pythagorean theorem. And beta is from pi to 3 pi over 2. So beta is in the 3rd quadrant, somewhere there. Keep an eye on them. So for part A, I need sine alpha, so I use the triangle. Opposite over the hypotenuse. In the 4th quadrant, sine is negative. So that's done for this one. Cosine beta from the triangle adjacent over the hypotenuse. But we are in the 3rd quadrant. In 3rd quadrant, cosine is also negative. For C, they want us to find cosine alpha minus beta. This is cosine, the formula, plus sine. This is not cosine alpha minus cosine beta. So let's see, cosine alpha, they give it to us 3 over 5. Cosine beta, -1 over square root of 5. Sine alpha, -4 over 5. Sine beta, -2 over square root of 5. This is -3 over 5 square root of 5 plus 8 over 5 square root of 5. If you combine, you get 5 over 5 square root of 5. They cancel. So we get 1 over square root of 5. You can leave it like this or rationalize it. For D, they want us to find sine alpha plus beta. The formula for this is sine cosine plus cosine alpha sine beta. What's sine alpha? -4 over 5 times cosine beta, -1 over square root of 5. Cosine alpha, 3 over 5. And sine beta, -2 over square root of 5. So that's 4 over 5 square root of 5 minus 6 over 5 square root of 5. That gives us -2 over 5 square root of 5. You can either leave it like this or rationalize. More applications to this. We can be asked to verify the identity. Kind of like prove an identity as we did in the previous section. Cosine alpha plus beta over cosine alpha minus beta equals 1 minus tangent alpha tan beta over 1 plus tangent alpha tangent beta. So if I look at such identity, the first thing that comes to mind is maybe I want to start with the left-hand side. I want to start with the left-hand side. because I do know formulas for each one of them that we learned today. What is that? This is cosine alpha cosine beta minus sine alpha sine beta. This is the formula we learned today. And this is cosine alpha cosine beta plus sine alpha sine beta. So now, how do I get to that one? Notice I keep an eye on the answer. I need 1 there. To get 1 there, what we need to do, we need to divide this by cosine alpha cosine beta. That will make it 1. But if we divide one of them, one of those expressions on the right side by anything, we have to divide each one of them by the same thing to balance the fraction. So now what do we get? Let's see. On the top we get this cancels, we got 1. Not 0, but 1. Sine alpha over cosine alpha, that's tangent alpha. Sine beta over cosine beta, that's then tangent beta. And this cancels this cancels another 1, plus sine over cosine, that's tangent alpha. Sine over cosine, that's tangent beta. That's what we need. That's exactly what we asked to find. Another thing to do, find the value, another example, of cosine sine inverse of 1/2 with no calculators plus cosine inverse of 4/5. How do you find the value of this without using calculators? Since we're dealing with inverses for sine and cosine, let's recall that sine inverse of any function, any angle, is always bounded from negative pi over 2 to pi over 2. And cosine inverse of any angle here is any x is bounded from exactly 0 to pi. Those are important to keep in mind. Now, to simplify such expression that is given here for us, we can always assume this is alpha and this is beta. Watch carefully how I'm going to work with this. So we say let alpha equal sine inverse of 1/2. And since alpha is like a sine inverse function, so it's kind of like it goes there, this means alpha is going to be from negative pi over 2 to pi over 2. Important to list the conditions. Important to list the conditions. And beta is cosine inverse of 4 over 5. So from here, beta is from 0 to pi. Now, from the first assumption here, alpha equals this, by definition, sine alpha is 1/2. By definition, cosine beta is 4/5. Notice, like, I'm working from negative pi over 2 to pi over 2, and sine is positive. That tells me something here, that we are really just working in the first quadrant, because in this quadrant down there, sine is negative. So that gives me more restrictive condition on alpha. So alpha must be somewhere in there. For this one is 0 to pi, but cosine is positive. So that's the pi. Cosine is negative in there, so this tells us that beta must be in the first quadrant. And back to what I'm trying to find. I'm trying to find sine or cosine alpha plus beta. So I need cosine alpha plus beta. We can write the formula down. Cosine alpha cosine beta plus sine, oh no, not plus, we switch to sine. Sine alpha sine beta. So let's see what is given. Cosine alpha is not given. So, but I do know sine alpha. So we can draw a triangle here. Sine is the opposite over the hypotenuse. So this would be 3. Cosine beta adjacent over the hypotenuse. So that would be 3. Let's see, we get cosine alpha adjacent over the hypotenuse. Cosine beta. Both are in the first quadrant, so everything is positive. Cosine beta from the second triangle, adjacent over the hypotenuse, minus sine alpha is 1/2. Sine beta, opposite over the hypotenuse. So that gives us 4 square root of 3 minus 3 all over 10. You can be asked in a more general way to write something like sine of sine inverse of u minus cosine inverse of v. This expression as an algebraic expression. But you might say, wait, that's already an expression. Yes, but it's not algebraic. It involves trig. So we need an algebraic expressions containing only u and v. So we don't need no more trig, no trig in there. I want to clean up all the trigs. To do that, as we did in the previous one, I assume this is alpha and this is beta. So let alpha equal sine inverse of u. Okay, sine inverse of u. What is alpha here as a restrictive thing? Negative pi over 2 to pi over 2. And also from here, this is equivalent. This arrow means equivalent to say sine alpha equals u by the definition. Okay, notice u here. U is from negative 1 to 1 because it's sine. Sine goes always between negative 1 and 1. Also, let beta equals the cosine inverse v. So here beta is from 0 to pi. And this is equivalent to say cosine beta is v. Notice also v between negative 1 and 1. So if you're asked to put conditions on u and v, that's what u and v are. Now what we need to simplify, or rewrite this sine alpha minus beta. So I need to find sine alpha minus beta. What is that going to be? Well, before we do this, from this one here, when we said sine alpha equals u, that means u over 1. So you can draw a triangle here. This is alpha. Sine is the opposite over the hypotenuse. By the Pythagorean theorem, it's 1 minus u squared. Okay, and from the second one, we can draw a triangle for the second one. This is beta. V means v over 1, adjacent over the hypotenuse. 1 minus v squared. So, how do I find this now? It's sine alpha, cosine beta, minus cosine alpha sine beta. Sine alpha is u. Cosine beta is v minus cosine alpha. So we can use the triangle in the upper right corner. Cosine is the adjacent over the hypotenuse, so it's 1 minus u squared. And sine is the opposite over the hypotenuse, so it's 1 minus v squared over 1. And that gives us what we need. You don't have to simplify further. This is in the simplest form. Notice something here. Students might say, how do you know cosine is positive here? If we draw a circle here, alpha, notice how alpha is between negative pi over 2 to pi over 2. In these two quadrants, cosine is positive. In these two quadrants. And if we draw one for beta, beta was from 0 to pi here. In these two quadrants, sine is positive. And that's why we only use the square root of 1 minus v squared. So those are good applications, or actually in general, enough applications about the sum and difference identities for sine and cosine. What about tangent? Can we do the tangent? Yes, there is one for tangent. So if we do tangent alpha plus beta, the formula for that is tangent alpha minus plus tangent beta over 1 minus tangent alpha tangent beta. If it's minus tangent alpha minus tangent beta, 1 plus tangent alpha tangent beta. So these are identities for tangent, sum and difference. So if this is plus, matches the top, minus matches the top, and the bottom one gets switched. Let's try to prove, let's say tangent alpha, just an application, minus pi is tangent alpha. So let's see what we get for this one. Tangent alpha minus beta pi. I'm going to use the form right above it. It's tangent alpha minus tangent pi over 1 plus tangent alpha tangent pi. But tangent pi, what is tangent pi? Tangent pi, if you forgot that, it's sine pi over cosine pi, and sine of that is 0. So it's 0, and tangent alpha again times 0. So that gives us just tangent alpha over 1, which is tangent alpha. Another application, find the exact value of let's say tangent 70 degrees minus tangent 10 degrees over 1 plus tangent 70 degrees times tangent 10 degrees. So how to do this? I'm gonna look at this one and compare it to the forms given. It looks like the second one, the right hand side, like tangent alpha minus tangent beta. So this is like alpha beta. So the formula for this is tangent alpha minus beta, because it matches this. So alpha minus beta. So what is alpha here? Alpha is 70, beta is 10. So what do we get? Tangent 60 degrees. If you forgot what tangent 60, you can write it as sine over cosine, if you like, sine 60 over cosine 60. So what's sine 60? You're supposed to know it. It's the square root of 3 over 2, and its cosine is 1/2. So the 2's cancel, and the answer would be the square root of 3. So these formulas that we learned here, we're going to be using those in subsequent sections. So it's really important that you master how to use them. And every time you're trying to do a problem, do not just look up the formula and kind of like do it without writing the formula down. That's what a lot of students do. They just look at the formula and they start substituting on the paper within the formula itself without writing it down. So it's important that you write it down before you start doing problems, and make sure you know it before you start. So that's an important part. This way it helps you to memorize the formulas. Even if you think you don't need to memorize them, it helps to memorize them, because when you start looking at random questions, if you look like the chapter test or chapter review, then you can the formulas will be kind of like come to your mind to see which one would be the easiest to use, or which formula is more appropriate for me to use to help me to solve the problem.